All right, today we're diving into a really cool AI that can learn to play thousands of different video games, and get this, it does it almost instantly. It's a new framework called Portal, and it's not just a small step forward for game AI, it's a whole new way of thinking.
So how on earth is that even possible? I mean, think about it. Platforms like Roblox are just exploding with user-generated content. You have millions of brand-new, unique games popping up every single year. For AI, this has been a total nightmare. How could you ever train one AI agent to master a universe of games that just keeps growing and growing?
Well, the old way just doesn't work. Not anymore. The classic methods that beat games like Go or StarCraft, reinforcement learning, they're amazing, but they are incredibly slow and super expensive. We're talking weeks, sometimes months of training on these giant computer clusters just for one game. You just can't scale that. It's a wall.
Okay, so if the old way is a wall, how do you get past it? Well, what if you could just open a new door, a new gateway entirely? That's the whole idea behind Tencent's Portal framework. It represents a huge shift in how we even think about building game AI.
And yeah, the name is not an accident. The researchers said it themselves. They picked the name Portal because it's like a single gateway that connects one AI to thousands upon thousands of different game worlds, letting it jump between them and adapt almost on the fly.
And here it is. This is the big, clever idea at the heart of the whole thing. Instead of that slow, brute force method of teaching an AI to play a game through endless trial and error, Portal teaches a large language model to simply describe how to play the game. It totally flips the script, turning a really hard decision-making problem into a much simpler language problem.
And that leads to this really powerful new way to think about the AI's job. See, it's not the player anymore, frantically hitting buttons and reacting. Nope. With Portal, the large language model is more like an architect. It's standing back, looking at the big picture, and designing the high-level strategy, the actual blueprint for how to win.
So what are these blueprints made of? They're built using a tool that's super common in game development called a behavior tree. Now, if you're a game dev, you know exactly what this is. For the rest of us, just think of it like a really simple but powerful flowchart for an AI's brain. It's just a set of basic rules that tells the AI what's important, what to do next, and which specific actions to take.
Let's actually walk through the logic on this one here. You can literally follow the AI's thoughts. It starts at the top and has to make a choice. Do I see an enemy? If the answer is yes, it follows the path on the left. Pick a target, then shoot. Boom. Simple. If the answer is no, it just follows the path on the right. Find a new place to look for enemies and move there. It's clean, it's logical, and you can see exactly what it's thinking. And this is what the language model actually writes. It's not generating some messy, complicated code. It's writing this. It's a simple, human-readable code they created called a Domain-Specific Language, or DSL. This is really the magic sauce. It's easy enough for the LLM to write it correctly, but it's also powerful enough to be translated directly into that visual blueprint we just looked at.
But here's where it gets even smarter. Portal knows you got to use the right tool for the right job. So for simple stuff, like checking if an enemy is nearby, it uses basic, reliable rules, the kind a human would write. But for the really complex, messy stuff, like navigating a chaotic firefight, that's when it switches to a tiny, efficient neural network that can adapt on the fly. It's a hybrid, giving you the best of both worlds, the solid logic of code and the flexible intelligence of a neural net.
Okay, so the AI has its blueprint, but a plan is just a starting point, right? What happens when it fails? How does it actually get better? Well, that's where Portal's self-improvement loop comes in. This AI doesn't just follow a plan. It learns from its mistakes, thinks about it, and tries again.
They call this process the reflection cycle, and it just runs over and over. First, the LLM generates a strategy, that behavior tree. Then, the AI agent goes and plays the game with that strategy. The system watches what happens, analyzes the performance, what worked, what didn't, and finally, it feeds all that info back to the LLM, which then refines the plan for the next round. Generate, play, analyze, refine. It's a constant loop.
And the feedback it gets isn't just as simple, you won or you lost. It's way more sophisticated. It's a dual feedback system. First, it looks at the hard numbers, right? The quantitative stuff like kills, deaths, objectives. But second,
And this part is so cool, it uses another AI, a vision language model, to literally watch recordings of the gameplay and give high-level strategic advice. It's like having an AI coach reviewing the game tape.
So does having an AI coach actually work? Oh yeah, the data here is pretty clear. This chart shows the before and after, just one single cycle of that reflection process, and look at the jump in performance. High-level strategic skills like map control and team coordination shot way up. The AI isn't just learning to aim better, it's literally learning to think better about the game.
So, the theory is really impressive. That learning cycle is clever. But this is where it all matters. Does this fancy new method actually deliver when things get real? Let's check out the proof.
And this, right here, this is the money shot. Every single one of these screens shows a totally different first-person shooter game. Different rules, different maps, different objectives, all made by different users. And the exact same Portal-generated AI is playing all of them, and playing them well, basically right out of the box. This is an insane level of generalization. It's the holy grail of AI research, and something the old methods just could not do.
What this all comes down to is a truly staggering jump in speed and efficiency. The old way, training an AI for a single game, took weeks, maybe months. This new way can be done in minutes. Just think about that for a second. If you're a game designer, you can just describe a new enemy's behavior in plain English and have a working AI ready to go almost immediately. The whole development cycle gets crushed from months down to minutes.
Now, obviously, this is a massive deal for the world of gaming, but the real story here, the really big picture, goes way beyond just making better video game bots. When you look at what the paper concludes, you start to see that this is a whole new pattern for how we can build and control smart systems in general.
So let's just quickly recap the key takeaways here, because they're pretty big. We've got way faster development, we've got that incredible generalization, but it also means we can create way more diverse AI behaviors just by changing a few words in a prompt. And maybe the most impressive part is how it handles teams. The LLM can design a single cohesive strategy for a whole team of AIs and then create individual complementary blueprints for each one.
And that brings us to what might be the most important point of all. The researchers make it very clear that the core idea here, using a language model as a high-level architect, can be used for a lot more than just games. Think about any field that has what they call hierarchical control problems. That's just a fancy way of saying a big task that needs to be broken down into smaller steps. We're talking robotics, automated warehouses, self-driving cars, the list goes on.
So that leaves us with this one final, kind of mind-bending thought. This paper proves, without a doubt, that an AI can be a brilliant architect for playing the games we create. But what happens when we turn the tables? What happens when we give that same AI architect the tools to create the games themselves?
What kind of worlds would an AI architect build? What rules would it come up with? I want to hear your most creative or maybe your most terrifying ideas down in the comments. And look, if you want to stay ahead of the curve and actually understand breakthroughs like this is what we do here at VibeDot. So do us a favor, subscribe, and make sure you ring that notification bell so you never miss out on understanding the blueprints of our AI-driven future. Thanks for tuning in.